Hello and welcome to this little tutorial on BPMN. Now, this of course is an episode in a series, and if you've been following, you've learned lots of things. And today we're actually going to combine a bunch of things like sugar, spice, everything nice, plus chemical X to create something even more powerful. Today we're going to focus on boundary events. Now, boundary events are at the most powerful when you combine them with other stuff, which is why it's a good idea to check out the video on events already, so they cover what they do. And subprocesses, because understanding those will really help you understand how boundary events work and how they're implemented. Today we're going to talk about of course, interrupting boundary events. We're going to talk about non-interrupting boundary events. We're going to talk about combining events with subprocesses, and we're going to talk about some of the events that we didn't cover earlier. Error events and compensation events, both of which rely heavily on boundary events as a concept. So let's get started. We're going to begin with interrupting boundary events, and we're going to start with a very, very common use case, which is a vampire out and about, getting some food, just chilling. And as we all know, vampires can only really stay out during the night because sun burns them. So in this scenario, we say, okay, we'll go and look for food. We'll wait until dawn. Once dawn happens, we go back to our crypt and then we're safe. Now, the problem with this process is that we could be out looking for food and then dawn could come up and then kill the vampire, and we don't want that. So this is the first sort of start of how to think about boundary events, because this is sequential. We have a task here out looking for food, and then we have a timer wait until dawn, and these happen one after another. But we don't really want that. We actually want to wait till dawn while we're looking for food. We want to do these two things in parallel, right? And more importantly than that, because we can't just add a parallel gateway, we want this task to be stopped as soon as we have 1 hour to dawn. So how do we do that? Well, I'm going to remove these two. I'm going to drag this. I'm going to pop it here on the side, and I'm going to connect these two. So what I've just done here is I've created a boundary event, and what this is going to do is it's going to say, okay, well, first of all, it's connected to here. So we've moved this around a bit to make it so that this now happens in parallel to this, right? If I go back to token simulation, you'll be able to see that once we arrive here, two things are active. The task, we could complete the task. Let's say we get food early. We find somebody wandering around who looks very tasty. Vampire eats that person, and then no problem, we go back to our crypt a little early, maybe catch up on some TV or something. Now, the other option is that we actually, we haven't gotten food yet, but dawn is approaching. When that happens, this triggers. The timer event basically is running as long as this task is active. And so as soon as 1 hour before dawn, we interrupt the task and then we continue down our process. And that is how interrupting boundary events work. Usually is a good way of saying we have a certain amount of time for this task. And then if we run out, then that's great. But that's not the only task type to use with boundary events. There are others, and they are also really, really useful for specific use cases. Now, while the timer is great for things like a deadline approaching or something that's local to the process, or something that the process understands, like a certain duration or a date in the future, there's also a way to have boundary events be able to interrupt a task from another process. Now, if you've been paying attention, the event you use if you want to have an external process interact with another process is a message event, and message events can also be boundary events. So if I drag and drop a little event here, I'm going to change this to a message event, and I'm going to say that the Slayer is arriving. This is bad news for our vampire, and therefore we're about to have a fight. So after this, we're going to have a wee fight. So fight the Slayer. And that's probably a user task. And obviously once we've fought our Slayer, we'll just go back to looking for food because, you know, it's hungry work. So let's put that here. Great. Okay, so the way this works now is while the timer event works essentially by assessing the current state of the process, this can be triggered from an external source. So if I, let's say, start this, I now have 3 things that could happen. I could get my food, go home, watch TV. I could maybe fight the Slayer. So the Slayer is arriving. Great, we stop looking for food. We have our fight, and then we return back. And let's say by the time we return back, then we got 1 hour to go. And this is a really, really good use case. As well as that, there's the final good use case, which is the signal. Signal, again, like message, is going to wait for a call, like a broadcast of some kind, and then it's going to do stuff. So if someone is shouting fire. So if someone's shouting fire, we are obviously going to find a new place to go. So find a new place. Great stuff. And there we go. So now we have the 3 main types of boundary events. We have a timer, which works by essentially a parallel event that is waiting for a time in the future that may happen, or a duration, right? So that would be a due date, for example, or let's say we have 10 minutes to complete this task, or else don't bother. Next, we have a message. That's another an external process or an external service that is sending a message to say, stop doing this task and do something else. And then finally, we have a broadcast, which is basically saying to anyone working on this kind of task, stop and do something else. They're the 3 main use cases for that. But of course, this is just the beginning. Interrupting boundary events are great, but there's something even more powerful, non-interrupting boundary events, which function completely differently and have completely different and way more powerful use cases. So let's get into that now. So I have a new process. This process from the perspective of the Vampire Slayer, right? The Vampire Slayer, of course, their job is to head out there and slay some vampires. Now, while they're doing that, they might get hungry. Now, as we learned from the previous example, we can solve that problem because we can wait. After an hour, we can stop doing our vampire slaying and get some food, right? And once we get our food, we can then go back to vampire slaying. Okay, and we can do that a couple of times. Now, here's the problem with this particular process, is that a slayer must be ever vigilant and therefore always needs to be ready to slay at any point. And the problem is, if we are getting food, according to this process, we're not allowed to slay vampires because it's not available. So what we want to achieve is we want our slayer to always be able to slay a vampire when they see them, but if they want to get food, they should also do that as well. So how do we do that? Well, this is where we're going to change this task, which, as you can see, has a full circle around it, to a dash circle, right? And this dash circle means non-interrupting. We've now changed the task from interrupting to non-interrupting. The second thing I'm going to change is I'm going to delete this. I'm going to add an end event, and I'll explain why in a few minutes. But now what we've done is we've added an additional thing we can do in parallel, which is key. So let's talk about it. So once we arrive here, we have the same 2 options as before. The first option is I can finish slaying and go home. The second option is the timer expires, it's been an hour and I'm hungry, so I get food. The difference here is if we trigger this, a new token is created. Previously, it cancelled the token that was here and we went this direction and got food. But now we are running 2 things in parallel, technically 3, but we'll see. We are both slaying vampires, so ever vigilant. We are getting food, fantastic. And also we're waiting for this timer. And this means that we, every hour, or we can now do a thing where it's cycle time. Previously, the timer event for the interrupting boundary event had a specific time in the future where it would trigger. This event can take a cycle, let's say every 50 minutes or every hour, for instance, and now we can get food every hour while always being available to slay vampires. This is pretty powerful. So this is the main difference. Now, the reason I had to change this is because if you add this back, and this is a big thing to look out for because it can cause real problems to the process, you can end up sending way too many tokens. So here we have our slay vampire. Key thing is, once this non-interrupting event triggers, it does not interrupt this task. So this token stays there. We then get food. If we then go back into the task, we now have 2 tokens here. So now we're slaying twice, and this could end up creating multiple tasks. So we don't want that. This is why when you're using a non-interrupting boundary event, be aware that you're creating a new token, and you need to make sure that it goes off into the night. So yeah, but that's not the only way to use it. As before, I'm going to talk about how to use the other boundary events also in a non-interrupting way. So while slaying our vampires, other things can of course happen, and let's try a new boundary event, and let's do a message event. Now, a message event, as we remember, is another system that is trying to talk to us, or another process of sending a message in to tell us something. And this is going to be a vampire friend, because not all vampires are evil. Vampire friend says hi. And we are going to go down here, and this is going to be hang out with vampire friend. Okay, so now if we were to use this as a interrupting boundary event, we kind of know what happens here. We basically complete dereliction of duty, we give up on slaying, and we go down and we hang out with our vampire friend. Not appropriate, we don't want to do that. So instead I'm going to change this to non-interrupting again. And now this is where things get a little pretty cool and pretty complicated at the same time, because now we're going to go into slaying, and now we have a potential of 3 different options. We have the potential just to head off home because nothing happens. We have the potential of getting some food. Great stuff. We did that before. That was great. And also a message comes in from an external service that says, hey, let's hang out. We trigger that. We go down and we hang out with our friend. Now, because we're still here, the timer is still activated, so we can also go get food. So now we have a whole bunch of things that are available. And if you look at what's potentially possible in this process right now, we could maybe hang out with more vampire friends. We could get more hungry. We could eat our food. We could complete our mission. And all of that is possible and all running in parallel. And it's important to remember that when you're using non-interrupting boundary events, what you're doing is creating essentially a parallel branch that sort of is triggered by an event of some kind. And we see here that the message events are the ones that are triggered from external services are telling you something that is important, but let's say not so important that you need to stop slaying vampires, or that it's a timer has gone off and we need to go and get some food. So that's quite nice, and this is sort of shows the initial power of those kinds of tasks and those kinds of events. But that's not everything. This is just the beginning, because I told you at the very beginning that a very good idea to look at when it comes to this video is, first of all, events in general, because these are all executed in the same way that I showed you in the first video. But now I want to talk about how you can combine these with subprocesses to create something that's really, really cool. So we're going to do that next. Now for this explanation, we're returning back to our vampire process, because this vampire unfortunately has the potential of death, because we've kind of forgotten a very important part of vampire life, which is while we're here, it's very important to make sure we get home by dawn, because if we don't, we burn up and die. But if we end up going up here and fighting the Slayer, and dawn arrives while we're fighting the Slayer, we die, because we don't have a timer there that's stopping us. So this is a big problem. We're pretty good when it comes to looking for food, but we completely lose track of time. So what I want to do is I want to make sure that no matter what I'm up to, whether fighting the Slayer or it's looking for food, that I'm always aware of the time, and I'm able to make sure I get home in time. And the way we do that is by using subprocesses. Subprocesses can scope what we're doing in a way that makes those boundary events even more powerful. So let's start off by grabbing a subprocess, and I'm just going to get rid of this for now. I'll add it back in later. I want to put in the core elements of our evenings as a vampire, and I'm going to copy this and put it in here. Okay, so there's our subprocess. So this is subprocess called night out, and we're very hungry, so then we go in here, we then have a start event that goes here, we look for some food, and we fight a Slayer, and then we also connect to our crypt. Now I've removed the timer events. You're probably thinking, well, that doesn't make any sense. We're all going to die. But actually, no. So in this case, what I'm going to change is I'm going to add the boundary event, not to the lookout for food, but here to the subprocess. The point of the subprocess here, unlike the ways I described it in the previous video, is not to, let's say, to hide a bunch of stuff from viewers. It's actually for scoping a bunch of tasks so that I can catch them all in a single boundary event. And you can see that here, I now have a timer 1 hour before dawn that is now not only waiting for this task, but it's active as long as anything in here is happening. So how does that look? So once we go in here, we start our process, we go looking for stuff, and you can see the timer is already active. You can see the little plus sign there. So I can go and fight my Slayer, it's still active. I can come back around, and the same timer is always active. So if I go up here and I'll fight my Slayer, then I could end up triggering the timer event, stopping what I'm doing and heading back to the crypt. So this is a really, really great way of being able to scope a bunch of tasks. And this can also be done with non-interrupting boundary events. So let's say we have another timer, because we can have more than one non-interrupting timer. And this could be... Now, these events can also be non-interrupting as well, of course. You can attach a non-interrupting event to a subprocess, which is pretty handy. So that could be like a message event here. Non-interrupting message is here. Great. And this then can trigger something. So this could be non-interrupting message. You hear other vampire shouting. And then maybe you run away, or you can help them. It depends on the vampire, but we'll be vigilant and just run away. So, and then we can do that every time we hear another vampire screaming. So that's quite nice. So then we can have a whole bunch of things. Now I want to show you one interesting thing as well about sort of the a bit of a pitfall of using boundary events, and that is losing track of tokens and how to kind of fix that. Because one thing I could do is I could trigger this, right? And I could be running away. And then I could leave the subprocess. Just because I leave the subprocess doesn't mean this token disappears, right? Once you start that parallel branch, it's up to you to make sure that parallel branch is taken care of, either if this is still relevant or not. Now, if we're already back to our crypt, running away is no longer relevant. We don't need to worry about it. So what we can do is we can use other events we talked about, like the terminate event. So if I change this to a terminate event, once we get back to our crypt, that'll mean we're going to stop doing all the other weird stuff we've been up to. So running away is an option, but now we're done with food. So we're going to head back to the crypt, and then we're going to stop everything. So be aware that when you use non-interrupting boundary events, you're going to be creating lots of other kinds of parallel branches that need to be sort of taken care of and need to be understood, but you could end up getting a bit lost or having random tokens keeping your process alive, or tokens that may cause deadlocks and stuff. So be aware. Now, up until this point, we have been working with events and subprocesses that I've already talked about. If you want to know how they're executed and that sort of thing, you can just look at those other videos. But now I want to talk about two events that are particularly good when combined with boundary event concepts and with subprocesses, and that is the error event and the escalation event. So let's talk about how that might work. Now, as a vampire, so far we've been pretty cocky. We're assuming that we fight the Slayer and we always win, but that may not happen. So instead, we actually might need to take into account how the fight went. And we said, how did the fight go? Okay, and we have here a victory. And now we have a loss. Sorry, that goes here. Lost. And let's just make it a little more space. Okay, so in this scenario, we've got a problem where we've lost. Now, what does that mean? Well, it means that we need to throw an error. And what this means is we're going to go through here and find the error event. The error event throw is an error that's very different to every other kind of throwing event. The message event has a throwing event that comes from another process. Okay, so that's an external. The timer event is always catching. It doesn't have a throwing comparison because it's just waiting for time. But error events, they bubble up in scope. So once this is thrown, what this is going to do is going to look for a boundary event to catch it. And so I'm going to add this here, and then this is going to be lost fight. And there we go. And that's an error boundary catching. And that's pretty good. So this will then trigger this and be caught. And then once this is caught, we will try to, well, we'll actually just turn to dust, because that's what happens when you lose a fight. Okay, so what this does is it basically, this is automatic. You really have no ability here. So let's talk through exactly what happens and why it's different to other events. So we start here, we do our fun stuff, we then fight our Slayer. Okay, great stuff. While fighting our Slayer, don't forget there's a bunch of things that could happen. We could run away if we hear other vampires shouting. We could realize it before dawn and just bolt back to our crypt. But we could also lose. And if we lose, we go over here and we end up triggering this event, which throws it here and we turn to dust. So what's happening? This is an event that we're throwing up to the next scope. In this scenario, in a subprocess, if you throw this error, the next scope is the boundary event of the subprocess, right? And there's loads of other things that could happen. So for instance, let's say we're getting back to our crypt, and let's imagine that we don't make it in time, because getting back to our crypt, we've got to do it in an hour, right? So let's do this, and let's say we have 1 hour to get back to our crypt. And if we don't, we're basically going to turn to dust. Now, as you can see, we already have a turn to dust right here. So what we can do is we can have, and this is particularly powerful, an event subprocess, which I've talked about before, that waits for an error event. Okay, and this is going to be turn to dust. So this is going to catch any event of death. So let's, for instance, get rid of this turn to dust, add this one, and this is going to catch this, and then it's going to rethrow it. Great, so this is going to be dead. After 1 hour, we're also going to add another error boundary event, also called dead, because we died of sunlight. Okay. So let's talk through the different possibilities here and why they matter. This thing here is a global catch, which means it's waiting for an error event that could happen from multiple places. But I've put it here to emphasize how the scoping mechanism works. If we start our process, right, we go here, we go up, we fight our Slayer, and we lose, it's going to throw this error. It's then going to look for this first scope, which is here. Now, if it finds that, it's then going to catch it and then going to go here and throw this error. But where does this one go? Well, this one goes to the next scope, which is actually this thing here. So let's take a look at how that looks. We go here, we lost our fight, we're dead, we get thrown to here, we turn to dust, and we die. Okay. Now, what happened there is each error tries to get caught by the next layer. And the funny thing is, if this didn't exist, if we say remove this, it'll still look for that scope, but it'll then continue rising to the next scope. So actually in this case, if we even remove the boundary catch, it actually still will look until it's caught. So if I go to here, it'll throw this and it'll immediately caught by the global catch. So this is just how these error events work. And we also have, because we have this global catch, it means that if we throw the error event from anywhere, so let's say we head off because it's time before dawn, but we don't make it back to the crypt in time. We throw this and we're dead, and we still catch it. We turn to dust right here. So it's a global catch, which is really, really nice. It means you can throw error events from various places. Now, error events have a few different ways of being thrown. I'm going to talk about that now. So let's talk about implementation of these error events. An error event, if you ignore all the stuff except for the error here, it needs a global reference, right? And this is going to be dead is our name, and dead all caps is our code, right? So this means that the global reference to this error is dead. Now that's a throw, so a throw will always need a keyword to throw. So when you just throw, you don't throw an error event, you're throwing an error event called dead. When we go here, this catching is different. It can either catch a specific error called dead, or it can catch everything. If I don't have an error event at all, then it'll catch if I have nothing set at all, it'll catch whatever error that shows up. And then this will do the same. We'll say we'll catch dead. And this one here, also the same. We will throw dead. And up here, this one can catch, if we leave this with none, it'll catch whatever error gets thrown. So we'll leave that there. So it's a global catch. So error events must throw a specific error, but error catch can catch either one specific error or all errors. Okay, so it's quite powerful in conjunction, especially with subprocesses. It can scope an area to be able to wait for a specific error in that. As well as that, errors are always interrupting, so they will always interrupt what's happening. You can't throw a non-interrupting error. So this thing here is always going to be interrupting. Okay, but what happens if something happens that maybe is a little more black and white? Let's say we're not quite dead. Well, that's where escalation events come in, and we're going to talk about that next. Now, while error events are great at dealing with black and white issues like being dead or alive, there is some gray area. For instance, things that might happen that we can deal with without needing to interrupt everything. Error events are specifically used in cases where we can no longer complete what we're trying to do, and we have to stop it and deal with it externally somewhere else. But let's imagine that while we're fighting our slayer, they happen to have garlic, and this is a bit of a disaster for a vampire. So I'm going to add a conditional event. So a conditional event waits for a condition to become true. So this would be slayer has garlic. Okay, now if this happens, we don't need to necessarily stop the fight, because we can still fight. It's not great news, but there is a cure. And so what we can do is we can catch this and then throw an escalation event. Now the escalation event throwing is exactly the same as the error event throwing, in that it checks the next scope, and it always throws up scopes as well. They're fundamentally exactly the same, except for the way they catch. So while an error event will always catch and interrupt, a conditional event can catch, an escalation event can catch and be non-interrupting. So you see here that we've got a non-interrupting conditional event, and this is going to be deal with garlic. Okay, and let's put that there. And the only way to deal with garlic is to add olive oil. So we add olive oil to that. So let's just use a user task here, and that should solve our garlic problem. So garlic dealt with. Now the nice thing is this is happening in parallel for everything else, but also doesn't stop anything from happening. So if we just have a little wait state here and we press play, we arrive here, we are doing our thing, the slayer has arrived, we start our fight, then we discover, oh my goodness, she has garlic. So it's going to trigger this, which is subsequently going to throw this. Similar to an error event, it's going to look to find this, and we're going to add some olive oil to it, and then we're good. So we can see that this can happen multiple times, and it gets thrown to the next scope, and we can catch that without interfering with the fight. So this can happen during the current task. So which is quite nice and very different to the error event works, because an error event will always be thrown and then interrupt the task. We have arrived at our final event of this tutorial, and that is probably a very complex event to explain, but very easy to use, and it's called the compensation event. And now I didn't mention this until now because this is one that basically requires you understand boundary events. So I'm going to add it here. I'm going to add a compensation throw. Okay, so this is a compensation throw event. It's an intermediate event, and when it throws this event, it does a really special thing, something no other event does. The scope for this is very, very different. Remember, a message, the scope is it leaves the current scope or comes into the current scope from somewhere else. The conditional event just deals with the scope that we're currently in, just the process. Timer event is just the time. Error propagates up from a low scope to a high scope. This thing here goes backwards. It looks at what's happened in the process, and it looks at everything that has been activated, and it tells every task that has been activated up to this point, compensation is happening. Now we deal with the catching of it. So now we know that this thing sends a message to all tasks that have finished, right? All of these. So how do we catch it? Well, we catch it in the same way as any other event, which is we add it like this, compensation. And this would be take a shower. Because if we have smothered olive oil all over ourselves, well, we should take a shower. And that's key because if, for instance, we haven't smothered olive oil on ourselves, we're actually kind of okay. We don't need to take a shower because, you know, we're fine. We're probably all right. But we definitely do if we've done the olive oil thing. So the way this works is, and I think this is really impressive, is we will do our thing. If we go down the happy path, which is that we are lucky enough to just enjoy our day, no one disturbs us, we go back to our crypt, and then we trigger this, nothing actually happens, right? Because no other tasks have this catch, okay? Now, if we do trigger this, and we see that we actually go up here, the Slayer does have garlic, and we trigger this. As soon as this is triggered, this continues, and we're done. The key thing here is this boundary event is only triggered once a token is left, right? So once this is complete, it's basically available. This then becomes activated. So then as we go along to here, oh, we do our thing, we complete, we've done our fight, great. We arrive here. Now when I click play on this, it's then going to trigger this event because it's going to throw this. The token simulation doesn't quite cover this correctly, but it's going to trigger this, which is then going to activate take a shower. So then we'll take a shower, and then we're done. Yeah, and that is how that works. So it's really powerful. This event has this little dotted line here for the very good reason that a token will actually never go from this task to here. Kind of weird. It always completes because a token is just generated here from this. It's kind of weird, but it's just how it works. It's really easy to implement. You actually don't need any implementation beyond what we've just shown. But if you see, we have the ability then to sort of trigger very specific wait for completion is one, and activity reference is another. So you see that we can say the token stays there until the task that it triggers is complete, and you can even specify which specific task. So if you want, okay, I want you to make sure that this is the one that we deal with. So yeah, they're the options. So thanks for joining. I hope you've learned a little something about boundary events and a little something about vampire slaying. So yeah, thank you. I'll see you again.